In this video, we'll start going over what the functions of operating systems or system software are. And we will cover memory management and process management in this video. And then in our third of 3 videos in this unit, we'll go over hardware management and file management and user interfaces. So, what is an operating system? Well, an operating system is a complete suite of system software. Remember, we learned what the difference between systems and application software is. You put a bunch of it together that works with each other, we call it an operating system. A complete suite of system software that works on a specific type of hardware. That's called an operating system. You're familiar with many of these. Some popular examples. Windows, like Windows 7 or 8 or 10 that a lot of you use. Or OS X that you might be using on your MacBook Air. Or iOS that you might be using on your iPhone. Or Android that I know some of you have a Galaxy phone and are running Android. Or some of you may have heard of Linux. These are some of the more prevalent operating systems. Well, they aren't the same as each other, but they all have certain characteristics. So, one of them is that operating systems have to do memory management. This is not anything you normally see, but you can somehow feel it in the background. Now, what do we mean by memory management? Programs need memory. Remember that diagram from the last unit? There's lots of memory, and in the memory we have data stored, and we have instructions stored, and so on. And the computer runs through the program one step at a time and does whatever it tells it to do. Well, a lot of programs need more memory than there is physically available on your phone or your laptop or your desktop. There's usually not enough physical memory on a computer to handle all the requested memory for all of the programs running at one time. So what happens? The operating system fools the application programs into thinking they have all the memory they need. So each application program can pretend that it can address all the memory it needs, and the operating system accommodates it by paging the memory in and out from a disk drive. Remember, we've got lots of disk storage, but it's slower than memory, and the CPU can't address it directly. So, when we need more stuff in memory, we pull it in from the disk drive. Now, the operating system tries to keep the memory that's going to be used most often. Now here's a nice typo. The operating system tries to keep the memory pieces or memory locations that are going to be used most often in main memory and swap out the other pages when required. Now, if you're going to be using the same memory over and over again, it doesn't make sense to keep writing it to disk and reading it back. You want the stuff you use most often to stay in memory. So often, the operating system does this with an algorithm that's called the least recently used, or LRU, figuring something that you haven't used in a while, you probably aren't going to need to use again for a while. Now, swapping pages of memory is much slower than directly accessing memory. This is why adding memory to a system can often dramatically improve performance. Notice, not adding disk space. You may have a 1 terabyte disk. And that's great for you to store large videos, large sound files, movies, text files, and so on, graphics. But if you've got only 4 gigabytes of RAM, random access memory, and you're trying to run a lot of big programs, your system will seem sluggish. Going up to 8 gigabytes of memory means it has to do only half as much paging in and out. So adding memory to a system often dramatically improves performance. Some programs are real memory hogs and affect the performance of other application programs by forcing a lot of paging. If you're running a program that requires gigabytes of memory, and every time that program gets its turn to run, it swaps all of that stuff in and swaps everything else out, then when your other program gets started, it has to swap what it needs in. So there's an awful lot of programs that are bad actors, that memory hogs are what programmers call them. Hopefully you're not running too many of them, but there are still some of them out there. Now, how much memory can you address? Well, an application program can theoretically address memory based on how many bits are used in the operating system to represent a memory address. Now, you've all heard of, well, are you running a 32-bit operating system or a 64-bit operating system? Well, I remember back before 32-bit and 64-bit days. Suppose you had a 16-bit operating system. That means that it treats memory addresses by using 16 bits to give the address. Well, that means you could have 16 zeros in there, or you could have 00000000001 or 000000010, all the way up to 111111111. Okay, that gives you 65,536 different unique memory locations. 64K of memory, not megabytes, not gigabytes, 64K of memory. If you're running a 16-bit operating system, all you can address is 64K of memory. If you're running a 32-bit operating system, you can now address 2 to the 32nd power, 32 ones or zeros in a row, which comes to about 4.2 billion bytes, 4 gigabytes. Now that doesn't mean your system has 4 gigabytes of physical memory, but the applications programs can address that much of it, and maybe it will get paged in and out. Well, what happens if you have a 64-bit operating system? Now you can get 2 to the 64, 64 ones or zeros. And if you put 111111111 and figure it out, that's 18 quintillion bytes, about 16.8 million terabytes. A lot of memory. So far, nobody's used up that much, but it's only a matter of time. I remember working on the Space Shuttle program back in the 1980s. I was one of the programmers that did the onboard computer programming for the Space Shuttle, the guidance, navigation, control software, the autopilot that made the Space Shuttle run. And we used to deal with 128K of memory, not even a half of a megabyte. And that was all the physical memory that the computers on board the Space Shuttle had at the beginning of the Space Shuttle program. They got better over time, but for the first several years of the Space Shuttle program, 128K of memory. And now we're talking about 16.8 million terabytes, or 18 quintillion bytes, instead of 65,000 bytes. Yeah, computers have come a long way in my lifetime, and they're going to go a long way in your lifetime as well. Okay, that's memory management. Now let's talk about process management. More than one application program can be running simultaneously. I mean, you know this from running your laptops. You've got Microsoft Word open because you're putting together a report for something, and you're also emailing somebody, and you've got an internet browser open because you're doing some research online. You know this on your phone. You're texting somebody while in the background you've got some music playing. There's more than one application program can be running simultaneously, but they might all be competing for the same resources. They all need to use the CPU. They all need to use some memory, maybe not the same memory, but maybe the memory has to be swapped in and out. They might need access to the same peripherals. They might need to use the program counter, and so on. So operating systems implement algorithms to let programs take turns, and each one does this somewhat differently, and usually you have no idea how it's doing it. Just you're running 3 programs, it looks like they're running at exactly the same time, but what's really happening is there's some time slicing going on. Here, you get a few microseconds to run, then the next program gets a few microseconds to run, then the next program gets a few microseconds to run. Switching from one program to another requires saving the contents of memory that that program thinks is in memory, all of the registers in the program counter from one program, restoring them from another. This means taking a lot of stuff that was in memory, writing it out to disk, and then reading in from disk the state of the memory and registers from when you had your last time slice. This takes time. Swapping a program in and out takes time. Okay, that's the end of this video. We'll pick up with hardware device management in the third video.